both positive, so this is going to be a plus sign. And then I just put what's here. If this were one was positive, one negative, I put subtraction, but then in the parentheses, I would just put the things I see. That way I keep my signs straight without double dipping. Okay? Now, especially when I do foiling, we do foiling in a second. You got to be real careful about that. When you write that expanded step, sometimes it's easy to lose track of your signs. So this is square root of 7 times square root of 7. Okay? So distributed that to both terms, everything plus. Okay? Now this all comes back to our basic rules here, multiplying radicals. If the radicands are different, the product rule allows us to put them under one house as long as it's the same index. But it still has a house. If the radicands are the same, then that means we are doing a square root squared, something times itself, and so it releases the square and the index of 2 cancel out, leaving just the radicand. Blows up the radical sign. Both of those are useful here. So in this first one, are we still going to have a radical sign?
Yes.
Yeah. Different radicands, we can multiply them, but we still have a radical sign. And the new radicand is 77. Plus, here, we've got a radical times itself, square root of 7 squared. So what is that?
7.
Just 7. Right. No more radical. Now, before we move on, we want to see if we can combine any like terms. But before we can combine any like terms, we have to make sure that each thing itself is perfectly simple. Square root of 77. 77 is not a perfect square. Does it have any perfect square factors? If you're not sure, you can check the list in your, and that's not going to give you factors on that sheet. So it'll tell you that 77 is not a perfect square. But, sorry? 8? 8 squared is 64.
Yes.
Uh-huh.
Doesn't have the biggest.
Oh, well, you want factor pairs of 77.
Oh.
And remember, you can manually list your factor pairs, or you can get a list on your calculator by doing 77 divided by x. And the only factor pairs of 77 you'll find are 1 times 77 and 7 times 11. Are any of those perfect squares other than 1? No. So if it's not a perfect square and it doesn't have any factor pairs that have perfect squares, then you can't simplify anything. Okay? So either mentally go through the factors, make a pencil and paper list of the factors, or make do that number divided by x on your calculator and look at the table to get your factors. So if it's not a perfect square, does it have perfect square factors? If so, you can simplify part of it, but if not, you walk away. And 7, of course, nothing to simplify. And so now we ask, before we walk away, are these like terms we can combine? No, a radical and a non-radical. Not like terms, we're done. So you see, we're putting all those multiplication and simplification and addition rules together now. Okay with that? Okay, so let's jump into the special products. Let's start with foiling. Foiling binomials that include radicals can get really messy. So you want to be really organized. Okay? The first step is the long step to write out, but it keeps things nice and clean and organized. So, okay, so let's do square root of x plus square root of 5 is one binomial times 2 times the square root of x. Oops, no parenthesis there. 2 times the square root of x plus square root of 10. A binomial times a binomial, but it contains at least one radical sign. So I'm going to leave myself lots of room. I'm going to end up with 4 terms. Multiply the first ones, then the outside ones, then the inside ones, then the last ones. So that's square root of x times 2 times the square root of x. And as I say, what I do is these are all plus, but if one was plus and one minus or 2 minuses, I would first note is it positive or negative and just put a plus or a minus, and then I just put just the positive terms in parentheses. That's how I manage my signs. Here, my outside terms are both positive, so I put a plus sign, and now I just put square root of x, square root of 10. The inside terms both positive, put a plus sign, square root of 5 times 2 square root of x. Last terms both positive, put a plus sign, square root of 5, square root of 10. Now you're going to simplify each little package using our multiplication rules. You're going to simplify them if they can be simplified. After you multiply them, then you simplify them. And then before you walk away, you see if you have any like terms that you will then combine with addition. Now, when you're multiplying, first do any outside numbers. So coefficients. What's the new coefficient here? 2, because it's just 1 times 2. Yeah. And then multiply your radicals. And note, are your radicands the same or different? Same. So will you have a radical sign or will it blow up? Yes. So square root of x times square root of x is x. So square root of x times 2 times square root of x is 2 square root of x squared, which is just x. Plus, no coefficients here, they're just 1. Both radicals, are they same or different? So you'll still have a radical sign. And your new radicand is 10x. Okay. New coefficient? Yeah, 1 times 2, still just 2. Outside number is 2. Is radicands, 2 radicals, different radicands? Still have a radical, and our new radicand is? And plus 2 radicals, no coefficient, different radicands. So we have what? 50 or radical 50? Yeah. Product rule says 5 times 10 under one house, but there's still a house. Okay. Now, look at each of these 4 little packages and see, can you simplify it even further? Okay. Not if it's just a term, but if it's a radical, see if any part of it is a perfect square or contains a perfect square.
5 times 2.
Mm-hmm. So, yeah, 1 times 10 or 5 times 2. Any of that perfect squares? 4 is a perfect square, but not 2. Yeah. So 2 times 5, 10 is not a perfect square. 2 times 5 doesn't contain any perfect squares, so 10 is locked in. Okay. And x, of course, is locked in as well. Same thing here, 5. Any prime number, you can be locked in even if it's not prime. I mean, 2 times 5, this isn't prime. It still has another factor pair, but it doesn't contain perfect square factors. Now, if it's prime, it's automatically locked in because its only factors are 1 times 5. Okay. So that's locked in. Okay. And this, what about this one?
25 times 2.
Right. This is not a perfect square, but it has a perfect square factor. So either off to the side or maybe right on top, whatever little method you use to just show this is the same thing as 25 times 2. It's not a perfect square, but it has a perfect square factor. I write that factor pair. I would change the value. 25 times 2 is 50. But I put the perfect square factor first, because then by the product rule, I can split those. And I root release, and I have my leftover bit. Okay. So now I have 2x plus square root of 10x plus 2 times square root of 5x plus 5 radical 2, square root of 2. Yeah, root and release the 25, but the square root of 2 is left behind. And now, before I walk away, I look at my 4 terms that have all been simplified, and do I have any like terms that I can combine? These right here? Well, they both have x's in them, but one has a 10 and one has a 5. So these are not like radicals. Yeah. They have to be exactly alike radicands to be like radicals. And yeah, these have x's and so does that, but you can't add a radical to a non-radical. So none of these are like, this isn't a like term with anything, because the other ones are radicals, and all of these radicands are different. So that's it. Okay, so try this one, and then we'll do binomial squared. So 5 square root of 3 plus 9 times 6 square root of 3 minus 4. In this case, we have 2 binomials. Only 2 of the 4 terms are radicals, but any radicals at all, we're going to FOIL it out, expanded form. Okay. This one has 1 plus and 1 minus, so be mindful of your signs. got coefficients on these radicals as well. Okay. So that's something to be aware of. This is what I was mentioning that I do with science. For my outside term, I say one's positive, one's negative, which means I write subtraction. But now I just write the terms. I don't put negative 4. I put 5 square root of 3 times 4. Because putting the subtraction sign already took care of the sign. That keeps these nice and clean. I'm not worried about what's positive, what's negative. Okay. I know it's going to be negative, so it's subtraction, and now I just put the positive versions in there. That's how I keep it straight. Inside both positive, put a plus sign. One positive, one negative, so I put subtraction. So now, clean up each of your 4 things. Coefficients first, and then radicals. And with the radicals, decide if the radicand's the same or different, because that tells you whether you still have a radical or not. This first one, we had a coefficient of 30. 5 times 6 is our new coefficient. And then our radicals, the radicands match, which means there's not going to be a radical sign anymore. Square root of 3 times square root of 3 is just 3. So we'll be able to multiply the coefficient of 30 times the freed, the released 3. Here, we had 2 numbers and a radical. Just gives us a new coefficient, but the same radical. Same thing here. And that was just 2 numbers. So we'll keep cleaning up. It's 90. It's 20 square root of 3. It's 54 square root of 3 minus 36. All right, check to see if there's anything I can simplify. Of course, not with just the plain numbers, but these have radicals, but those radicals are not perfect squares, and they can't be broken down. So nothing to simplify, so now I look to combine like terms. The numbers are one set of like terms. And are the radicals of these like terms? No, square root of 3, square root of 3. So which means I can combine their coefficients. Now it doesn't matter whether you write the number first and the radical second. Okay? A lot of times if one's positive, one's negative, I like to put the positive one first because I like to not lead with a negative if I can avoid it. But there's no mathematical rule of which one has to come first. Okay? Just make sure it has the proper sign. I'll go ahead and do the numbers first. Both of these are going to be positive, so either way. So this is 54. Yeah. So 90 minus 36, 54. And then combine negative 20 and positive 54 to get a positive 34 radical 3. And if you wrote 34 radical 3 plus 54, that's fine too. Okay? All right. Questions? Problems? All right, let's do binomial squared. Okay. So, binomial squared. Of course, as I mentioned before, for binomial squared, if you expand them and FOIL them out, and you get the correct answer, you will get partial credit. Okay. You want full credit, I need to see you using the pattern. Okay. So the binomial squared, the basic binomial is either A plus or minus B, be one or the other, squared. And given that, it fits this pattern. Mentally FOILing, it gives you A times A, so you've got A squared. And then depending on whether this is plus or minus, it's either going to be AB doubled or AB negative doubled. So it'll be either plus or minus 2AB. And then, of course, it's either 2 pluses or 2 minuses for the b, so that will always be positive b squared. So when you have a binomial square that involves 1 or 2 radicals, first, expand it out just like that. Just like FOIL, we did the FOIL expansion and then simplified each part. Here, put it in this expansion, and then you'll have 3 things to simplify and then combine any like terms. So, square root of 7 minus square root of 2. So seeing it's a binomial square, that means square root of 7 minus square root of 2 times square root of 7 minus square root of 2. So following the pattern, the formula, the mental foiling. Now I'm putting it in parentheses for a reason. We're not going to see the reason on this particular example, but be consistent across the board because it's a very important reason. It's not just because I'm being OCD. It actually has a mathematical need. Okay? So square root of 7, the first term, squared, is going to be plus or minus. And it's always going to be then a 2 because you're going to be doubling your A times your B. AB doubled. And then plus, always plus. You don't even have to worry about this being negative square root of 2 times negative square root of 2. That's going to be positive. If you put that on the plus sign, you don't have to put negative in here. All your A and your B are always positive. The formula takes care of whether it's plus or minus. Okay? So this would just be square root of 2 squared. And now, 3 little packages to simplify. Square root of 7 squared is minus, we've got a 2, and then we've got 2 radicals. So can we multiply these radicals? And do we still have a radical sign or no? And what's our new radicand? 14, right. Multiply 7 times 2 under one house, but you still have the house. Plus, careful, 2. And see if we can simplify 14. 1 times 14 is not a perfect square. 1 times 14, 2 times 7, no perfect square factors, so it can't be simplified. It's not prime, but it doesn't have perfect square factors. Can't be simplified. But we can combine those numbers. Now, the number is going to be positive, that's going to be negative, so it's a little preferable to keep that, lead with a positive. But if you wrote negative 2 square root of 14 plus 9, as long as they have the right signs, then that's fine too. This just looks a little easier on the eyes. Now this one has a coefficient in front of the radical, a plus sign, and then the second term is not a radical. But if it has at least one radical, it still follows that pattern and it should be expanded out. And here's where those parentheses are going to make a difference. Hint, hint. What is this new first term? What's the coefficient of the new first term? 9, right. This is where those parentheses really make a difference. This is our power of a product rule. Power rule says we multiply that power times, and we don't have powers in here, but the power of a product rule says when we have our base is in parentheses, and this entire term is our A, put it in parentheses because that entire thing gets squared. Huh? So if this were 3x, for example, 3x squared would be 9x squared. Same thing with this. That square belongs to both the coefficient and the radical. Huh? If you left the parentheses off, then it would only belong to the radical. But no, our pattern says it belongs to the entire first thing. So you have to square the 3, which is just a regular number. There's no index to cancel out, so that's just 3 squared. Square root of 5 squared is 5. So we got 3 squared, which is 9, and square root of 5 squared, which is 5. Squaring a number, the coefficient, then squaring the radical. Now here in the middle, we've got the 2 for doubling, the coefficient of 3, and just the plain old number 4. Those are all our outside numbers, so our new coefficient is 2 times 3 times 4. 24, yeah. We only have one radical, so there's nothing to combine it with. Okay, so it's just, this is like 2 times 3x times 4. 2 times 3 times 4 is 24x. One radical, nothing to combine it with or to obliterate it. Okay. So in this case, because there's one number and one radical, we've got 3 numbers to multiply. Always do the outside numbers first, and then deal with the radicals. And then here, plus 16. Of course, that becomes 45. It's 24 square root of 5 plus 16. Combine any like terms. Check to see if you can simplify anything. Of course, you couldn't here because it's square root of 5. It didn't combine with anything anyway. Okay. But you would always check, then combine like terms. 61 plus 24 radical 5. Or 24 radical 5 plus 61. Doesn't matter. Questions, problems, concerns, confusion? Yes?
What is this 11.4?
This is all part of 11.4. This is the second half of 11.4. First half of 11.4 was the addition rules. Second half is the multiplication rules. But as we're seeing, now that we're multiplying, we're still using the addition rules if we have to simplify at the end. So all those rules are coming together. Okay. So one last special project in 11.4, and then we're going to use, especially what we're about to look at right now, to do 11.5. Which we'll be putting some of these rules to use in a different context. So any binomial squared questions? Pattern? Like I said, keep that in mind as you're practicing your homework, that the requirement on the test will be that you show that pattern in order to get full credit. So don't avoid that when you're practicing the homework. So conjugates is our third special product. And conjugates are when we have the same a's and b's, just like with binomial squared, but instead of 2 pluses or 2 minuses, we have 1 plus, 1 minus. And if we were to FOIL that out, we get our a squared on the front end and b squared on the back end, but our ab and negative ab cancel out. No middle term. And because we have mixed signs, here we have 2 pluses or 2 minuses. Therefore, our b squared is always positive. But with conjugates, 1 plus 1 minus means that it's going to be mixed signs. It's going to be no middle term, so it just goes straight to minus, and it's still b squared, but it's minus b squared, and no middle term. And note that it does make a difference of squares, but again, I put it in parentheses. Okay. Now, if I give you these, say square root of 2 plus square root of 13 times square root of 2 minus square root of 13. If you FOIL this out and get it right, you will get partial credit. Okay. What I want you to recognize and to earn full credit is that, hey, these are conjugates. Same a's and b's, but one's plus, one's minus. Which means you can go straight into the pattern. You know this multiplies to make a difference of squares. So your first term, squared, minus, always minus, and then you're not don't worry about positive or negative 13. That minus took care of the pattern, the formula took care of the sign. This is just square root of 13 squared. Now, am I going to have any radicals left? No, because my pattern, my formula, is 2 squares. There's no middle term where I just have an a times a b. We have a middle term with a binomial squared, and when we're dealing with binomials that include radicals, that means our middle term is going to exist, it won't cancel out, and it will have a radical in it. Okay? This, however, because the middle term cancels out, and we just have the front end and the back end, which are both perfect squares, that means any radicals are going to disappear. And that's the power of a conjugate we're about to use in 11.5. The power of a conjugate is to kill radicals. If you have a binomial and for some reason you have to kill the radical, I'm going to show you why you would, then all you have to do is multiply it by its conjugate. Because now this becomes what? 2 minus 13, which gives us 11. No more radical. Now, if there were variables involved in this, you might not be able to get it down to one number. You might have, something x plus or minus something, but still, there'd be no more radical. The radical's gone. Let's do a couple examples of this, and then we're going to put that very information to use, one of the powers of conjugates. And the same power is going to be used in the next unit when we look at imaginary numbers, because all of these multiplication rules and patterns that are applying to general terms, now applying to radicals, are also going to apply to imaginary numbers. Okay, so let's do these. Let's do 3 square root of 7 minus 4, 3 square root of 7 plus 4. Doesn't matter which one's plus and which one's minus. Doesn't matter which one comes first. One's plus, one's minus. Same A's, same B's. We'll also do square root of 5x plus 3. That's square root of 5x minus 3. This one involves some variables. But still, same A, same B, mixed signs, conjugates. Recognize it, and rather than foiling, go straight to first term squared minus second term squared. Our first example had both things were radicals. This is one radical, one number. This one has a coefficient. This one has variable. But it all follows the same pattern. Parentheses matter. What's this new first term?
9.
The 3 gets squared, and the square root of 7 gets squared. 3 squared is 9, square root of 7 squared is 7, minus 16. Of course, gives us 63, minus 16. Whether just A had a radical, just B had a radical, or both had a radical, doesn't matter. If they're conjugates, there's no more radical. What's my new first term? Square root of 5x squared becomes 5x, right. Don't accidentally make this 25x. That 5 is not on the outside. If the 5 were on the outside, we'd have 25 square root of x. Sorry, 25x. But the 5 is on the inside. It's the whatever the radicand is, whether it contains a number, variable, or both, that's what gets released. The radicand is the answer. A common mistake sometimes I see is that you would write this as 20.